Welcome to virtual school. I'm Miss Halstead. Here are some things that we can remember from inequalities. So an inequality in one variable is like x is greater than 3. We graph it on a number line. If the equal sign is not included, we use an open circle, and included, we use a closed circle. So the concepts are similar with two variables, but because I have an x and a y, I need to graph my inequality on two axes. Because instead of a boundary point, we're going to have a boundary line. So you need to use a dashed line or a solid line. Okay. So go ahead and read the situation and highlight the things that are important to you. I notice that it takes Lisa 30 minutes to make a pair of earrings and 1 hour to make a necklace. And the total amount of time she has is at greatest 10 hours a week. Okay. And then for her materials, she can make 15 items per week. Okay. So I went ahead and said, I'm going to define my variables. So we're going to let x equal the number of earrings Lisa can make and y equal the number of necklaces. Okay. There are two constraints or two restrictions that I have when Lisa's making her jewelry shop, and one is the amount of time she can dedicate, and the other is the total amount of items she can make. So remember, the items have to be the most she can make is 15. So the total number she makes has to be less than or equal to 15. The time, 10 hours is the greatest amount of time she can spend, so this has to be less than or equal to 10 hours. Okay, we're going to go ahead and set up the inequalities for number 3. So it says that for the time constraint, I know that if I'm going to have an inequality that equals a total time, I put cost. You should put time. Okay, total time. That if I spend if I make one necklace and it takes me 1 hour to make it, it's going to be 1 hour's worth of time. Or if I make two necklaces and each one takes 1 hour of time, it's going to take me 2 hours, so on and so forth. So the amount of what I'm building times how much time is going to give me the total amount of time for the necklaces. So to simplify that, or to generalize, I can say that 1 for 1 hour times y will give me the total time for necklaces, plus it takes her 30 minutes to build a pair of earrings, but we want to make sure that we are in units of hours. So that would be half an hour times x has to be less than or equal to 10 hours. So that's the time constraint. Now we're going to move on to the inequality that describes the number of items. So looking back at our items, they have to be less than or equal to 15. And honestly, this one always trips me up, but it's just x plus y. It's the number of earrings we make plus the numbers of necklaces you make. So when our variables are described as the amount, you can just add them up together. Okay. So we need to graph these to figure out all the ordered pairs that are possible for Lisa to make. Okay. So I'm going to start with number 3, that one. So y plus 1/2 is less than or equal to 10. 1/2 x, excuse me. I like to graph using my slope-intercept form, so I'm going to subtract 1/2 x to the other side. So y has to be less than or equal to negative 1/2 x plus 10. I'm going to go ahead and graph that in. My b value or my y-intercept is 10, and then I'm moving my slope is down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. And I just graph in a whole bunch of points, because then my line is really straight. Okay. Do I use a dotted or a solid line here? I'm going to go ahead and use a solid line because we can equal those 10 hours. Okay. For the second one, x plus y is less than or equal to 15. I'm just going to find my x-intercepts. This is just another way to graph. So for x and y, I'm plugging in 0 for x and then 0 for y. So for this one, I'm plugging 0 plus y has to be less than or equal to 15. So my y value is going to be 15. I'm going to plug in 0 for y. So x plus 0 is less than or equal to 15. So x is going to be 15. So my x-intercepts for this line are 15, 0, and my x-intercept is 0, 15, and my y is 15, 0. So 15 and 15. Basically, you lose let's see if it goes straight. There we go. We lose one earring for every necklace we build. Okay? Or one necklace for every earring we build. One necklace for every earring we build. I'm going to go ahead and label my axes. My x is earrings, and my y is necklaces. The number of. Okay. All right. So next part is shading. So for both of these lines, it says less than, and then for the second line, x plus y is less than or equal to 15. If I subtract the x to the other side, I get negative x plus 15. So I can see that both of these inequalities I need to shade below the line because it says less than. So below the green, and below the purple. Where is there double shading? So we're going to go below the green. Would be like that. And then below the purple would be this in the blue. So where's the double shading? It looks like the double shading is right here. So any ordered pair in this area would work as a combination for Lisa. Okay, we call this area right here the feasible region because it's possible, feasible. Okay, so the double overlapping part is the feasible region. So we're going to list 3 combinations of ordered pairs. Remember x, y, that's earrings and necklaces. So some combinations, I'm going to be like, okay, here's a point 8, 1. 8, 1 is in the feasible region. Okay, choose another point. Maybe right here. That would be 0, 10. Another point right here. 6, 1. Means she can make 6 earrings and 1 necklace. Does that work for her time and her money constraint? Well, let's see. Okay. So for time, remember we had our time inequality. Let's grab that 10 hours there. Okay. So 1y plus 1/2 x is less than or equal to 10. We're going to test our point here, 6, 1. Make sure it works in the time constraint. Okay, so 1 times 1 for y, so making 1 necklace, plus 1/2 times 6, making 6 earrings, has to be less than 10. It takes me 1 hour plus 3 hours. And is that less than or equal to 10? Yes, 4 is less than or equal to 10. So we're good on the time restraint. All right, now on the items. X plus Y has to be less than or equal to 15. So again, X is 6 pairs of earrings plus 1 necklace has to be less than or equal to 15. So 7 items, is that less than or equal to 15 items? Yep. So that is a combination she can make. It might not make her the most money, but it is possible within her constraints. Okay. So domain and range. Domain is X values and range is Y values. So in this situation, Lisa has to make greater than or equal to, if I go back and look at my graph, where are the values graphed in the X direction? It looks like from 0 to 15. That's the least number of earrings she can make and the most number of earrings she can make. So we're going to write the domain as, I'm going to cross that out. X has to be less than or equal to 15, but greater than or equal to 0. The range, I can see that the most number of necklaces she can make is 10, and the least number of necklaces she can make is 0. It doesn't make sense for her to make a negative. So 0 is less than or equal to Y, which is less than or equal to 10. Okay. All right, I want you guys to fill in number 9 really quick. Okay. First, we defined our variables. Then we identified the constraints. Then we went ahead and wrote the inequality statement, so the system of inequalities. Then we graphed your system to see the feasible region. Then we looked at the set of solutions or ordered pairs that can be found from the feasible region. Oh, okay. All right, I'll leave it here for this. Last part is from your homework or your independent practice from your slides. So for your slides, you're going to do the work and then just upload a picture of what your work is, okay? So the first one, we're going to graph the inequality in how many variables? Well, 1, 2, because there's an X and a Y. So the B value is 2 and the slope is 3 over 1. So I'm going to start at a positive 2 and then I'm going to go up 1, 2, 3 to the right 1 and then negative 1, 2, 3 and left or negative 1. Do I use a solid or a dotted line here? I'm going to use a solid line because of the equal sign. So I'm going to use a solid line. Should we go through all? Okay. And then I'm going to test a value. So right here, 0, 0. I'm going to test it in my inequality to see which side I need to shade. Okay. So 0 is X and 0 is Y. So I'm going to do 0 is greater than or equal to 3 times X, which is 0, plus 2. So 0, that's 0, is greater than or equal to 2. Is that true? That is false. So 0, 0 is not part of the solution. That means that we need to shade on the other side. Okay, so we're going to pick 3 possible solutions from our feasible region. Okay, this is the feasible region over here. So any ordered pair like negative 2, 0 or negative 3, 2, or how about one on the line right there? 2, 0 is part of the feasible region because the boundary line is solid. Okay, so I'm going to test this point 2, 0 in my inequality. So we're going to test 2, 0. I said this backwards. So right here, this is wrong. This would be 0, 2 because it is on the y-axis. 0, 2. Okay, so my x is 0 and my y is 2. I'm going to plug in 0, just kidding. 2 is greater than or equal to 3 times 0 plus 2. All right, that's 0. So 2 is greater than or equal to 0 plus 2 is 2. Is 2 greater than or equal to 2? Yes, it is. So that 0.02 is a combination that works in my inequality. All right, last one for today. So graphing inequalities, you just graph one inequality and then the next, okay? So we're going to graph y is less than 3x plus 2. So again, my b value is 2 and my slope is 3. So 1, 2. And then up 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Did I do a bad job here? Okay. I'm going to go ahead and graph in my inequality. And do I use a dotted or a solid line? I actually use a dotted line here because the points on the boundary line are not included in the solution set. Okay, do I shade above or below? Okay, you can test a point, or because I have my y isolated, I can go ahead and shade below. I know I'm going to shade below. All right, let's go ahead and graph this guy. We're going to start at -2, and then the slope is -1 over 1. So down 1 to the right 1. So negative divided by a positive. Negative divided by a positive. Negative divided by a positive. Do I use a dotted or a solid line? I use a solid line because the equal sign is included. Okay, do I shade above or below the line? I'm going to go ahead and shade above. So the feasible region is going to be, all right, let's see if we can get this in here nice. All right, below the purple and above, let's just use that color, above the blue. Where's the double shading? It happens in this yellow area right here. Okay, and that is our feasible region, the double shading. Now we need to find 3 ordered pairs. So I'm going to take this one right here, -3, +3, comma, +3. Another solution would be like on this line right here. So 0, comma, -2. And is this a solution right here? 0, comma, 2. Okay, let's test this one just to verify. So what you do to test this time is we plug it into both inequalities. So I'm going to start with y is greater than 3x plus 2. And then we also need to test the point in y is greater than or equal to -1x minus 2. We're going to test 0, comma 2. So this is algebraically how we would test to see if we have a solution. Okay, so x is 0 and y is 2. So I'm going to plug in 2 is less than or equal to 3 times 0 plus 2. 2 is, let's see, 3 times 0 is 0, plus 2 would give me 2. That 2 is not less than 2, it's equal to. So that one doesn't work. We're going to try the other one. 2 is greater than or equal to -1 times 0 minus 2. 2 is greater than or equal to -2. This is true. So is it okay for us to be true in one equation but not the other? No, we have to be true at the same time. So is 202 a solution to our system of inequalities? No, it is not. We need to choose another point. It's not because it was on the dotted line, remember? Okay, this over here, that is the solution. 5, comma, negative 5. All right, and that's what you're doing today. If you have questions, you can message me through Google Classroom. You can message me through email. You can meet up with me, I think, on Wednesday for office hours. All right, sound good? All right, I'll talk to you guys later.